In this section, we want to work together on the Start Game button and custom properties in Photon. So in this part, we create the Start Game method. Here we also create a coroutine called change scene coroutine. It takes the active scene index and loads the next level using load level in Photon network. And in the Start Game method, we call the coroutine. The only thing to keep in mind is to make sure you enter this line of code here. The automatically sync scene property helps ensure that the scenes are synced correctly for all players in a room. This way, when moving to the next scene, not only the master client is transferred, but the other clients move along as well. So add this line of code in this part. We go back to Unity and assign the Start Game method to the Start Game button. Just if you remember, we forgot to use the nickname value change method for the nickname, which is assigned randomly. So for this input field, in the value change section, we add an event by pressing the plus button and connect the nickname value changed method to it. Apparently, this method is defined as private. So we go to script and change it to public. We go back to the editor and perform the assignment again. So in this part, we assign the start game method for start game and the nickname value change method for nickname input. Now, if we go back to the script, by pressing the start game button and calling this method, and with this line in here, we can move to the next scene. We go back to Unity and continue with the work. The only object that might be a bit unclear is this one. And I think it's better to give it a more meaningful name so its purpose is clear. So I change its name to local scene observer object and add a new script called local scene observer to it. Then open it in Visual Studio. This script acts as an observer for the object that will later serve as an observer for the player. And separate instance of it is created for each user on each system. So we need to use the singleton pattern at the beginning and create an instance of it. In this script, instead of mono behavior, we use mono behavior upon callbacks and override the enable and undisable methods. If you press F12, you'll see that other functions are called inside the bodies of these methods. So we don't modify them and use these as they are. Here we subscribe to the scene loaded event so that whenever a new scene loads, we can have the object to observe created this way. Here we unsubscribe from the SceneLoaded event. So whenever we move to a new scene, considering that this object isn't destroyed in each client until the end of the game and acts as an observer for object to observe, immediately after a new scene loads, the scene loaded event is raised using this code. And here, object to observe is created. We go back to Unity and assign the object to observe here. Just look guys, here we are creating the object to observe using Photon network. And according to the Photon documentation, the object to observe prefab must be saved in a folder called resources and have a Photon view attached to it. So we go back to Unity and create this folder. So here we create a new folder called resources by right-clicking. Next, we add an object called player observer to the hierarchy panel and save it in resources folder. Just make sure to also add the Photon view component to this object. Then override the prefab, delete it from the scene, and assign it to the object to observe field. Double-click on Player Observer to go to the prefab editor. Add a new script called Player Observer to it and open it in Visual Studio. Look guys, this script acts as an observer for the player that spawns. It basically manages the instantiation and distraction of the player during gameplay. And it works locally for each player. So here, we create an array of players of type GameObject and call it player prefabs. We also create a new field called player object and a Photon view. Here we don't deal with these lines. If you don't want to use Photon view variable like this, you can easily replace mono behavior with mono behavior upon callbacks. This way, you can access Photon view directly and you don't need these lines anymore. Here, based on the role of this script, we add a new method called instantiatePlayer. For its arguments, we use a variable called spawnPoint of type vector3, which holds the position where the player will be instantiated. We use this variable to store the player that is instantiated, and this method should be called on the local player. So here, we use ownership and this mine property from Photon view. This property refers to the local user and can be either the master or any client. To start, we set the player's spawn point at the origin coordinates and use 2 for the y value. Of course, later we'll work more on the spawn points for the player. So up to this point, what happens is that first we move to the next scene. When the new scene loads, the scene loaded event is raised, and the object to observe, which is the player observer, is created. It is responsible for instantiating and destroying the player. We go back to Unity and create the player object. Naming it player blow. And since this object will be spawned using Photon network, it needs to have a Photon view component and be saved as a prefab in the resources folder. So we add this component to the object and place it in the resources folder. Now, we open the scenes folder and create a new scene. And we rename it to Scene 1. We select the player object and remove it from the scene. We open the build profiles from the file menu. By clicking this button, we also add Scene 1 to the scene list. We close this window, double-click on Scene 1, and in this dialog, save the changes made in the sample scene. Here, we add a plane. By pressing the F key, we focus on the object. We save this scene and go back to the sample scene. We select the player observer object and assign player blue to the player prefabs array in the player observer script. We build the game once. In the editor, we also click play. If you notice, local scene observer is placed under the don't destroy unload object, and it isn't destroyed until the game stops. It always acts as an observer for the scenes. Now, if we create a room here, and on this side, by pressing Find Room, we join the created room. Then click the Start Game button on the master player. You'll see that when moving to the next scene, at first the player observer object is created via the local scene observer object. Then the player observer creates the player blue. So this player observer is generating this player object, and in the same way, this player observer handles it. If you notice, for this player, isMine is set to false, which shows that this object belongs to another user on a different system and isn't this user. While for this user, isMine is true, which actually represents the local client. Next, we want to specify that this player observer with isMine set to true is creating this player blue with isMine also set true. And in the same way, this player observer is also creating this player blue. So we stop running this and go back to Visual Studio. So in this script, at this line where the player is being created, we need to send additional data while instantiating the object. Here, we set the group to 0, since this game doesn't consist of multiple groups and is kept simple. For the next parameter, we send the view ID in an array as the data. We go back to Unity, select the player blue object and open it in the prefab editor. Here, we create a new script called player controller and open it in Visual Studio. In this script, we want to set the reference to the corresponding player observer right when the player object is created, so that we can access the methods we'll add later in the player observer class. So here, first we create a variable of type Photon view with the same name. Then we define the player observer. Next, for this variable, we use the find method in the Photon view class to access the instantiation data that was sent when the object was created. We assign the player observer accessor so that we can access the methods of the player observer class here. So, the player observer variable needs to be defined as public. Now, if we go back to Unity and build and run the game once, and press the Start Game button, you'll see that the value assigned to the player observer field points to this object. And in the same way, we have this object for this player as well. We stop these runs and maximize Unity. So in short, what happens is this. First, the local scene observer uses this code to create the player observer object. Then the player observer creates the player object at this position and with this rotation. And it also sends data along with it. Here, it also uses the data that was sent and applies it to the player observer accessor. Now, we can have this as private. Now, we go to the player observer script. Here, we want to actually create the players according to the selection we have in the room using the selected index. So we go back to Unity and duplicate this object twice. We name one player underscore red and the other player underscore green. We double click on the player observer object and open it in the prefab editor. We go back to the scene and return to the player observer. If you remember, in the player item script, we used custom properties to store the player index so we could access it throughout the game. And we also defined the key for it called player index. Now, here we want to use the custom property and the key we created to retrieve the stored index and select the player according to this index. So instead of 0 here, we replace it with this code. Later, we want to use other spawn points here instead of this one. We save the script, go back to Unity and run the game once. Here, we select the player at index 2 and click the Start Game button. As you can see, at this time, instead of player blue, player red is selected, and the game is working correctly. Now, we go to scene 1 and work on the spawn points. We create an empty object in the scene called spawn points, and by selecting this object, we add another empty object called player spawn points. We select this object and add a few spheres. In the Materials folder in Assets, we create a new material and name it Blue. We apply it to a sphere, duplicate it a few times, and place them in different positions. We select the subject and add a new script called player spawn points. Then open it in Visual Studio. Here, we create an instance for this script, and then we also create a list of transforms to store the spawn points. In the wake method, we set the instance to this, meaning this class. And in start, using the for each loop, we add all the objects that are under the subject to the player spawn points list. Next, we define the getSpawnPoint method and use an index as the input argument so it can be used to select any spawn point. We save the script and go back to Unity. Let's run the game up to this point. If you notice, in player spawn points, all the spawn points are added to the player spawn point list using this for each loop. Next, we want to remove all the sphere collider components from these objects. So we select all of them and delete the sphere collider from each. Alright guys, let's rename all of the subjects to player start point. Next, we want to disable the mesh renderer component for all the start points. So we go back to Visual Studio. Here, for each item, we disable the mesh renderer component. We go back to Unity. To have this scene properly set up in the game view, while the scene is set up, select the main camera and press Ctrl Shift and F to align the camera with the scene. Alternatively, you can choose Align with View from the Game Object menu. Click the play button and run the game. If you notice, not only have the player start points been added to the player spawn points list, but all the mesh renderer components have also been disabled. We stop the game and go back to Visual Studio. In the player observer script, here, instead of this point, we use the getSpawnPoint method from the player spawn points class. For selecting the index, we can use the creator actor NR property, which is assigned number for each player who joins the room, starting from 1. Okay guys, instead of the creator actor in R property, you can also use owner actor in R or controller actor in R. In here, we'll stick with creator actor in R. We save the script, go back to Unity and test the game once more. If you notice, the player is created at this point, which is spawn point 1, and everything is working correctly. Let's use the build and run option from the file menu for the second run, and create and launch the game. As you can see, the master player who joins the room first spawns at player start point 1, and the second player who joins the room later spawns at player start point 2. From index 1 onward, these positions are assigned to the players accordingly. If you want the player spawn to start from index 0, you can subtract 1 from creator actor in R here, so that the first spawn point isn't left unused, which we don't want to do here.